This is solving another system of equations using matrices. It's problem number 27 in chapter 10, section 3. So step number 1 is to write the augmented matrix. I want to get the upper left, this corner here, to be a positive 1. I notice that I have a negative 1 in row 2. So I'm going to switch row 1 with the opposite of row 2, and there's the result. And you can see now that since I did that, I've got a positive 1 in the upper left corner. So I'm getting ready to do REF, row echelon form, where I have these diagonals as 1. So I've got the first part of the diagonal as 1. I need the terms below it, the entries 2 and 5, to be 0. So I'm going to multiply row 1 times 2 and subtract row 2, replacing it with row 2. So here's my work. I did that work over here, 2 times row 1, and then the opposite of row 2. Collecting those, I get 0, negative 1, 11, negative 25, and I place that in row 2. Now I need this 5 here to be a 0, so I'm going to take 5, multiply it times row 1, and subtract row 3, replacing row 3 with the result being 0, negative 9, 26, and negative 79. And so we're going to take that and we're going to write the matrices over here, and there I've replaced it. So I've got this first column exactly the way I want it, 1, 0, 0. I'm now going to work on the next entry, this one, that needs to be a positive 1. Since it says negative 1, all I have to do is do the opposite of everything in row 2, and so I just did. You can see, and I did not even write a new matrix, I just made that entire row the opposite of what it was. Now I need this entry here in row 3 to be a 0. For the row echelon, I need to have a 0 below that 1. So I'm going to do 9 times row 2 and add that to row 3. There's the work, there's the result, replace row 3. Oh, but before I do that, I realize both of these terms are divisible by negative 73, and when I do that, I have 0, 0, 1, negative 2. So this is what I'm going to replace row 3 with. I always try to simplify whenever I can, and I saw that that row was divisible by negative 73. So I replace that into row 3, and I have 0, 0, 1. And at this point, I've got, this is row echelon form because I've got the diagonals of 1, and below the diagonal, every entry is a 0. But now I'm going to work on reduced row echelon form, which means I'm going to make the entries above the diagonal to be 0 as well. So if I take row 2 and add it to 11 times row 3, I do the work here, I get a result of 0, 1, 0, 3, which means this entry now, where it said negative 11, I can replace that whole row with this row, and I now have a 0 there. So I do that. And lastly, I need to get rid of the 2, the negative 2, and the positive 5. So I need to make this, in this row, a positive 2. And when I collect those, that'll go away. And I need to make this third row, this entry right here, to be a negative 5. So here's the expression. It's row 1 plus 2 times row 2 minus 5 times row 3, and replace row 1. I show my work here over on the right hand side, and I have this in green, exactly what I was saying I was going to do here in blue. There's the result, 1, 0, 0, 10, and now I'm going to replace this first row with this new row here, 1, 0, 0, 10. And what you might notice here is I now have a diagonal of 1s, and above the diagonal are all 0s, and below the diagonal are all 0s. So this is the solution to the system. It's reduced row echelon form, and this column are the solutions. This is the first variable, the second variable, and the third variable. So here's my ordered triplet, and that's the solution to the system.